A little introduction of me, but that's not why you're here. I've spent the last 41 years at Spectrophysics building lasers. And for the last 8 years, I've been part of John Lee's MKS Photonics business and learned a whole bunch of other things. But I'm a laser person from way, way back, of course. But I wear another hat. And that is I'm president-elect of Optica. That's exciting. That means next year I get to be president. They're going to send me a bunch of places. We have several of our board members here as well as our chief operating officer. And so it's wonderful that Optica's been able to support all of this. We're happy to get more suggestions on other things we can do for you. To reiterate one of the themes from earlier, it's certainly all about connections, but connections are all about people. And one of the things I love is that our CEO, John, talks about people, and it comes from the very top, and it's something we do in Optica as well. So unifying my two hats, people are very important, making connections between people is very important. That's really what it's all about. So I'm going to welcome our panelists to the stage. Both Tjark and Luke, please come on up and join us for the conversation. And please welcome them. Albert sends... Albert sends his regrets. Just yesterday, he became ill and was not able to join us, but we're going to have a lovely, intimate conversation anyway. So in order to get the introductions exactly right, I asked our two panelists to please show us a pretty slide of where they work and who they are, and we'll pull up the first slide, and let them tell you a little bit about how they come to be here, how they come to be at their company, and what it is they actually do. So could we cue up the first slide, please? And go ahead, Tjark.
Thank you very much. I'm Tjark Tjin. I have been the CEO of TNO now for a little bit more than 2 years. Before that, I was CEO of Sanquin, which is more or less a sort of a biotech company, which also includes the Dutch blood bank. Before that, I was Director General of Statistics Netherlands, so CBS we call it in the Netherlands. But I have a background in theoretical physics, quantum field theory. And so I'm kind of back on base with my technology firm. We're about 5,000 people large now. We're among the 5 largest RTOs in Europe, like Luc as well, and Fraunhofer and some others. And we do a lot of research on many different topics. We're like imec, only we're kind of more diversified. So we have a more diverse portfolio of topics we cover, going from defense to health to climate tech and all kinds of other things as well. So that's a very brief introduction.
Brilliant, thank you. Luc, we'll take the next slide, please.
Okay, so yeah, I think you probably know me from my talk this morning, but maybe some history on myself. So I started with imec 40 years ago, so I only had one job in my life. So I was finishing my PhD at the moment when imec was started, so I was part of the starting team. And so we created imec as basically a spin-off from the local university, the University of Leuven, and created imec as an independent research center, focusing, but very focused, as Tjark was saying, is one of the differences. I think we only work on chip technology, which is enabling, of course, a lot of innovation into many sectors. So in that sense, the fan-out is rather broad, but the focus is really all on chip technology. As I said, founded in 1984, 40 years ago. And I've been the CEO since for about 15 years now. Yeah, I think with the presentation I gave this morning, you probably have a good sense of what we are doing. So that we basically work with all key players, bring the entire ecosystem together, all material suppliers, equipment suppliers, fab companies, fabless companies, system companies, to kind of together drive the roadmap in the semiconductor industry. Total 5,500, 5,600 people at this moment.
Great. You can skip the next slide because you've covered who you are and where you come, and that's great. So The first topic is sort of the main topic, and that is how do we get from research to commercialization? Typically, RTOs maybe stop at technology readiness level of 6 or something like that, and you need companies to take the next step in what you're actually doing. So I want to hear a little bit about how successful you are, and in particular, what are the challenges you have in being even more successful?
Yeah, so it is usual for RTOs, in the past at least, to stop at 6, and this is the same for TNO, and we're kind of trying to get away from that, because it's not like a relay in which you pass the baton to somebody else and then they run with it, and your technical invention will become a real innovation in society. That's not the way it works. Usually, or often, too often, the baton drops. So nobody does anything with it, and that's a huge waste. When you look at the way we consider our organization and whether we've been successful in the past, of course, there are many successes that you could name. We're a big organization doing a lot of research with a lot of talented people. So it would be very strange if there were no kind of highlights that you could name. The thing you should ask is, given the fact that we've invested so much money and talent in this organization, does it yield enough given its resources over the past decades? And I would say that there is some room for improvement there, not only at TNO, but for all of us. And one of the things that I'm now trying to do is focus the organization a little bit more. We're diversified, and we will stay diversified. But still, you need a little bit of a focus in order to be successful. And imec is a great example of that. But in our case, it will also need focus in order to become more successful. And at the same time, work with these companies that will take up our technologies and work with them longer into the higher RTL scales, to make sure that the technologies that we've developed are actually also making it to the market, and at the same time giving us information on what the market is telling us on the lower TRLs. Because if you kind of separate yourself from the higher TRLs, then you actually are separating yourself from the discipline of the market, and I don't think that's a good idea.
Maybe as a follow-up, I can imagine that focus means not being so broad across so many areas, but in some sense we're talking more about depth, and that is going with a thing even longer. I can imagine as CEO, you may decide some areas are not as good as others, but how do you get that longer contact, or maybe getting to a higher level? How
so it is for us. It's stopping with activities that maybe we are not really the best at or very good at in the top, and also when you decide to continue with an activity. Of course, if you're talking about photonics, you're talking about a huge emerging field. Which part of that value chain will you then start to do? Or, you cannot do it all. Even in the Netherlands or in Europe, we cannot do it all. We have to kind of choose. So then you will have to look at, where do I have my comparative advantages as an organization, as a country, and as a region? And this analysis is not made so often. In our case, it wasn't made in the past. So we're now trying to do it and make sure that we find out where our comparative advantages are and where our future lies.
Luke?
Yeah, related to your question on TRL, how far do we go? Well, we are actually very much a customer-focused organization. We like to carefully assess in each of our partnerships how far do we need to go in order to create impact to our partners. And it very much depends on with whom you work. The majority of our activities actually focuses on what we call pre-competitive R&D. When we work with the biggest companies in our domain, think about TSMC, Maria, who was here this morning, but Samsung, Intel, all the big fabs. I mean, the model you propose there is very different from when you work with a startup company. So in that sense, we consider our goal as to drive the roadmap in a certain direction, align the ecosystem to it, and what is kind of a higher TRL level for certain parts of the value chain is lower TRL for others. And so it's very important to kind of adjust on how far you go, depending on with whom you're working. So most of the work we do is very much, as I said, pre-competitive, somewhat lower TRL levels, kind of working very close also with universities. I mean, the role of an RTO like imec is to kind of bridge that gap from lab to fab, take disruptive ideas in partnership with university and then validate those on industry-compatible infrastructure. And in this way, help the development teams of our partners to make the right choices and accelerate the introduction of new technologies in their manufacturing line. So in those aspects, we don't go to extreme high TRL levels, but when you talk about supporting startup companies, then we will go much further because they need access to these new technology platforms. For a lot of examples, like in the photonics area, especially also when we work with companies that don't have their own technology capability, but maybe companies in the medical space, in life science community, and so, then we can develop prototypes up to much higher TRL levels. So it very much depends on with whom you work.
That makes lots of sense.
It's also very much tied in to our main objective. Why was TNO created? TNO was created because in the beginning of the 20th century, people concluded that there was a huge gap between our academic sector and our private sector. It was kind of like they weren't talking to each other at all. So there was no overflow. There were no ideas coming from the academic sector into the private sector. And they wanted to kind of bridge this valley of death, as they sometimes call it. And so this is why TNO was created, to be kind of like the conduit for good ideas from the academic sector to the private sector. So this means that if you then take these ideas from the academic sector, you have to, stick with it until these ideas become really successful in the marketplace. And as I said, if you don't do that, then you never are exposed as TNO to the market and to the demand. And so this means that you can kind of stop at 6 and then go to your next topic and never mind whether it has been successful or not. So this is why I think that, of course, we are not primarily interested in the high TRL, but it's something that we are involved in some way on a less intense level, but still.
You brought up that in some ways you're the go-between between the very basic research and the applications. I would assume, having been in the middle of this, that there are some misspent expectations, maybe from both sides of the people who you're trying to get to communicate. And I was wondering if you can share, since we have lots of people in different parts of the value chain here, ways that you can overcome expectations that are not set correctly, either from the academic standpoint or from the commercial standpoint.
Well, I think in order to avoid wrong expectations, it's important to have very good discussions and set the right expectation level at the start of any engagement. And I think that is true for universities, but it's also true for industry. I think that it's very important also to try to be very concrete in those discussions, because there has been so much discussion also in these CHIPS Acts about prototyping, and what university calls prototyping or what industry calls prototyping is very, very different. So being very explicit in terms of quantifying exactly what the scope is of where you can create impact is very important.
I think that's great. The fact that the same word has different meanings to different groups is always a big challenge. Also,
in addition to that, I think success story has been not to view it as a project-by-project situation, but look at it as a long-term partnership with universities and companies. And that helps to kind of build trust and build kind of like a pipeline also. of interesting new developments because it's always moving forward. So you're working with the same companies more or less year after year. So I guess building long-term partnerships is also very important.
I think those are both good advice for everybody. And it's almost a segue to the second topic, but I have to tell a quick story, and that is I had a lovely dog named Roxy who, whenever she got out the door, would just go bolt down the street. And she would just run for fun, but every now and then she'd turn around and look to see if you're coming. And I thought it was the perfect metaphor for our job. We need to be out ahead of everybody, but we better make sure we're out ahead of everybody in a direction that they're all following us. So when you decide what you want to work on and what's your next hot topic or where your strengths are, how much do you depend on roadmaps from your customers? Or maybe they don't tell you what their roadmaps are, or maybe they don't know how much of it is then relationship instead of roadmap. And you were already discussing that having long-term connections with people helps with the relationship. I wonder what is the balance between where you get your information for the next topics?
Well, I think it's not one or the other. I mean, it is, of course, I would say the roadmap definition. I mean, we, as an RTO, it's one of our roles to kind of drive the ecosystem and align the ecosystem around a certain roadmap and set the direction there. I think that, and that's what we have been doing by bringing together the entire ecosystem. I mean, the innovations that we need now in the semiconductor industry and the R&D budgets that are required for it are so big that no single company can drive this on its own. So bringing this ecosystem together and then align the industry along this roadmap is one of the important roles we have as an RTO, I believe. But having said that, we should not become arrogant and say, like, we set the roadmap. No, we do that in name of the partners with whom we are working together with them. So, of course, we have a lot of internal expertise, but the input we have from all our industry partners, the input we get from the hundreds of universities with whom we work, I mean, all of that we need to bring together to build these roadmaps. Now, the semiconductor industry has been driven very much by this famous roadmap, Moore's Law, and I'm one of these believers that Moore's Law is not stopping. You just have to define what is Moore's Law, and it's not only enabled through scaling, but it's also enabled through all these new integration technologies, 3D stacking, 3D integration. But like this one roadmap we've marching along over the last couple of decades, I think is becoming much more diversified, depending on the applications. And therefore, I think on the application side, it's very important to also build up knowledge, because we should evolve from kind of a technology push towards a more application pull. And so therefore you have to understand these new applications, and not only AI, but also all the applications in health, automotive. And as an RTO, it's kind of impossible to be expert in all application domains. We have to build up the capabilities to speak the language, but we have to also partner with other research teams, with leading industry in those domains, in order to understand what are the needs for this long-term roadmap in all these application domains. So I think it's internal road mapping, but also very strong ecosystem, reliance on the ecosystem and partnerships. And it's through that bi-directional flow of information that we try to decide on what are the important things to focus on in the next decade.
Yeah, so I agree with that. We look at it like every company does it, I think. It's a combination of demand, so push and pull. You have a demand from the customers, and also you have a push where you have certain ideas of where the market may be going or the technologies may be going. And often, as a research organization, you have a very clear idea where the technology may go in a couple of years or 5 to 10 years. And that may be helpful to the customer as well. And you may be able to surprise them, but in the end, the roadmap is always very much influenced by the demand by the customers. And so it's not if this or that, it is both. But as I said earlier, there's another dimension that comes into play, and that's where are you actually, where's your comparative advantage? Because you can do all these analysis as the customer wants this, and we have our vision on where the technology may be going in a couple of years. It's very fine, but if you don't have a position in that market, then still you shouldn't invest maybe, or in some cases yes, but mostly no. So getting a clear idea of where your comparative advantages are, as I said, of your organization, of your country, of your region even, is very important. And that also will kind of influence the decisions you make on where to invest and where not to invest.
I wonder how formal, it's great that you're helping synthesize the roadmap with your customers. That's not something I'm used to as a laser person. How formal are your roadmaps? Are they published? Are there things people can read? And my background is that when we became part of MKS and suddenly all of the semiconductor roadmaps were very clear, those of us who had been in the laser business were incredibly jealous because of the fragmentation that we had dealt with. And so we were quite envious of our customers telling us explicitly things we needed. So how public are you with what you've synthesized with your customers? Or are you under NDAs and you're not allowed to share some of these things?
I would say it's a combination of both. Yeah. So of course we work with nearly everybody in our industry. At this moment we have like major meetings twice a year where we basically update all these roadmaps. That's kind of an internal meeting, but then the outcome of that we also publish at many conferences. So it's both, I would say. Yeah, but it's a very intimate process where we bring everybody together twice a year, where we update these roadmaps.
I think the roadmaps are constantly in flux, and
Sure.
this will be the same for us and for everybody here in the room. It's constantly evolving because this field is, and every technology field is evolving so quickly. And your position within the field also is evolving quickly, and then maybe the EU does something with new budgets, and then everything is thrown into the blender again. And so you will have to be very aware of the fact that everything can change on a dime, right now. And being flexible and being able to kind of change the course is also very important in this whole thing. So I'm not such a big fan of long-term roadmaps in this field, in this specific kind of area, because it's too dynamic. You do have to have a little bit of an idea. So like Luc presented, this timeline, right? So where the next technologies may come. But still, even that may be, may change next year when he stands here to present it. Maybe it will be different already because things change so quickly. So roadmaps are good to kind of like as a mental crutch, but they shouldn't be taken too seriously because they can change.
Well, I would question that a little bit. You asked us not to agree on everything.
I asked you not to agree on everything.
Exactly.
But I think these roadmaps are very important, at least in the domain where we work, because the investments in R&D are so big, yeah. And we have to make sure that the ecosystem is aligned. When we talk about introducing like a new lithography technology, EUV, ASML, preparing for the next version of high-NA EUV, it's very important for the material companies to understand when those technologies insertion points will be, because they need to make sure that their materials are ready in time. Typically, their R&D budgets are much smaller, and so it can be very catastrophic for them when they invest too early in getting a material ready. It's even worse when they're too late, because then their competition may be ahead. So having that alignment on timing for new technology insertions, I think, is very, very critical for the industry.
Excellent. Congratulations on your presentation to the new fab here in Malaga and getting to meet the mayor and all like that. But that brings us to the globalization question. Historically, you've concentrated in your home countries and then the rest of Europe, but you're all now doing things in Asia. or other parts of the world. And I wonder, what really is your globalization strategy? And what about challenges? Because, as we said, people are very important, and there's also funding challenges in other parts of the world. Can you give us some color on your globalization plans, please?
Well,
yeah, go ahead.
Okay, I already briefly talked about it about this topic this morning in my presentation. So indeed, we are mostly based in Europe in terms of our infrastructure, but already from the early days of our existence, we have positioned imec very much as a global R&D organization. We work with all the major players, whether they are in the US, whether they are in Taiwan, Korea, Japan, Europe. We try to bring together everybody at a global level, and we have been, for decades, we've been a global R&D organization. Having said that, I think imec has reached a size where it becomes difficult to do everything on one location, and this then comes together with kind of the opportunities that emerge with the various CHIPS Acts and interests from various places to kind of take a strong position also in the R&D in this domain. And so we are looking at those opportunities and partnering with some initiatives like this one. But we also have a very strong partnership in the Netherlands with TNO, where we have a major R&D facility where we work on some of the applications in a very strong partnership. We have initiatives in the US where we partner with certain universities. And I think it's very important, as the point that I tried to make this morning, that in this domain, we really try to work on a global level, because the industry is also global. And I think Maria showed a very interesting slide this morning on illustrating which region is contributing where in the value chain, and it's a very integrated industry, and I think that has been, to a large extent, the reason why the industry has been successful. It becomes so difficult. If everybody tries to do everything, it will lead to mediocrity. We need to really strengthen the strengths, focus on the strengths of a region, and try to have a strong position in the global value chain. I think that is the best way to tackle these phenomenal R&D challenges. You have to bring together the best of the best. You have to build critical mass. We've seen so much consolidation in our industry, on the industrial players. We should make sure that the CHIPS Acts are not going to lead to a decoupling of the regions, whereas there has been consolidation on the industry side. We might get decoupling on the R&D side, which I think would be completely inefficient. And so we are strongly advocating, let's collaborate, because that has been the success of our industry, and we have to make sure that we collaborate even more in order to enable the future progress.
Yes, these value chains are intrinsically global. This is true for semicon, this is true for photonics, and all these other fields will be global value chains. And every region will have certain comparative advantages. And as it was said in the previous panel, you will have scale advantages driving specialization. So this driving of specialization and the comparative advantage will mean that the different regions in the world will kind of take up different parts of the enormously complicated value chains. So what you will get is not strategic independence, as people are talking about now in Europe. What you will get is strategic interdependence. We will all be interdependent, and that's okay. That's even okay in a highly stressed global situation like we are having now. Maybe it is even preferable, because we depend on each other. So it might be actually good to have it for peace, because we all need each other, and it's a natural thing to happen. So the main question for me when it comes to our international strategy is, at which things are we very good compared to our global competitors or colleagues, or how do you call it? because we don't have to replicate all of us the same technology, all the same activities. We should really, I mean, at a certain point we will say, listen, we have 5 other RTOs in Europe or in the United States or whatever, doing the same as we are, but maybe even better. So why then are we doing it exactly? At the same time, there may be other things that we are doing that we are certainly leading. We are a leading innovator. We're really pushing forward the needle when it comes down to technology development. In that case, that might be some area that we would like to invest in. So I think it's a natural process of consolidation. Once the technology becomes more mature, then these economies of scale, as well as comparative advantages, will kind of take care of who does what, predominantly, of course, because it's never 100%, 0%, and that's okay. And then we get an internationally interdependent value chain, which is, I think, even for the geopolitical tensions that we are seeing now, very beneficial. Also, by the way, our infrastructure is mostly in the Netherlands. We do have foreign offices, but the infrastructure is mostly still in the Netherlands. But when it comes down to the contract research we do, about 60% of it is not from the Netherlands, so it's quite a large part of it.
I think the pilot lines, as we're setting it up in the European Chips Act, also is a good example of how we are kind of emphasizing complementarity between those pilot lines, between the first 3 pilot lines that have been announced, but also now what is being set up in photonics. It's, I think, a good example on how we are connecting some of the strengths across Europe into an integrated plan rather than compete against each other.
Jim, what a great panel so far. We have some questions in the public. Please remind us your name and company.
Hello. I'm Nathalie de Baas from Brussels Photonics, and I would like to thank you for this great panel discussion about collaboration. And as imec and TNO are also partner in the Photon Hub project, I would like to ask to you, according to you, how important is it to have a European innovation hub that bridge the industry and the research world together?
Well, to be very brief, very, very important. Yeah, I think we should go all out to try to create a good position in Europe in this technology, and several other technologies as well, by the way. Otherwise, we will miss out. You've all probably seen the Draghi report, and it's really not such a good situation in Europe at the moment. We really have to start changing our attitude regarding innovation and technology, and it will be very difficult. So, but this will be maybe one of these areas that we can really make a move.
Yeah, I agree. I mean, it's super important, and because it's one of those areas where I think we in Europe here can really have some very strong assets and can also create a lot of new opportunities, new startups in this field. So we need to have the technology platform to enable this. In these deep tech startups, I mean, you can create a lot of startups with 2 people in a garage, but in these deep tech startups, you need a mega garage to demonstrate your capabilities. And that's why these pilot lines are so important.
If you want to hear more about Photon Hub, they have a fantastic booth outside. Please visit it. We have a lot of questions. Jim, please remind us your name and company.
Hello, Brian Hall, Color Chip. So great discussion. Collaboration is wonderful as a first starting point, I believe. But how important is inorganic growth to your company over the next 5 years? And if it is, because there are so many wonderful companies here. I mean, small companies, 2 guys in a garage, 10 guys in a building, whatever they may be, a very, very intelligent group. How important is inorganic growth, and what would you say are the top 3 areas that may be interesting to you?
Oh, this is for you, I think.
Well, with inorganic growth, you mean acquisitions? Okay. Yeah, well, as an R&D organization, we typically don't acquire other organizations, although we have done it once with a major initiative where we had two R&D organizations actually in the Belgian ecosystem. We were focusing really on the technology, chip technology. We had another organization that was focusing more on the application, like cybersecurity, AI, Internet of Things. As there was this very strong need to kind of connect technology with system requirements, system technology co-optimization, we felt the need that we needed to expand and get more knowledge in terms of the application domains. So that's when we merged with the other organization. That was kind of a very good example of an inorganic transition in our growth. But that's kind of the only example that I can give.
Yeah, so maybe a little bit different than the question, but the big problem in Europe, in my opinion, well, especially in the Netherlands, let me talk about the Netherlands, but I think it's true for Europe as well, is that we do a lot of good fundamental research in Europe. I mean, we're leading, I think, in fundamental research in many areas. We also nowadays in the Netherlands, we have lots of startups, and in Europe as well. I mean, that's not the problem anymore. In 20 years ago, it was. 20 years ago, we didn't have startups in the Netherlands. And maybe this was also true for many parts of Europe. Now we have a lot of startups, but if you then look at what happens to the startups, you see that they don't grow, they don't scale, they don't become the next Google, etc. That's the major problem we face right at this moment. And this is also one of the reasons why the percentage of R&D of GDP is not growing, especially in the Netherlands, because these companies usually, when they grow, they spend a lot of money on R&D, and then, of course, this pushes the whole R&D portfolio of a country or a region. But in the Netherlands, we see, and in Europe, we see this problem very clearly. And I think consolidation of these companies, merging, acquisitions, and maybe even by a TNO, an organization like TNO, this is actually something that we are now going to do. We have a new strategy in which we actually are willing to acquire parts or whole companies in order to bring them to the next level when it comes to the growth cycle. Because in Netherlands, one of the reasons that they are not growing is that first they cannot get funding, and it helps a lot, it turns out, if TNO is behind a certain technology or a certain company to get funding. And the second is that they don't have equipment, lab facilities. It's a very small country with a lot of people and not enough buildings and not enough labs. Of course, we do have those infrastructures, so that might help them to kind of facilitate their growth quicker. And that is one of the major problems in Europe at the moment, I think. So yes, a little bit different than what you said, but still, I think you are onto something.
You have 3 more questions and 1 minute of time, so I'm going to ask fast questions and fast answers, please. Please tell us your name and company.
Ashkan from NVIDIA. So I think that the customer to R&D pipeline it breaks the laws of thermodynamics, because everyone has a lovely idea that they want to push from R&D into product, but the correct figures of merit and barriers of success are not communicated downward. We try to change that. So, and then the other part of it is when there's an international pool of money like these various CHIP acts, it's a nice spin on the flywheel. Everyone gets super excited. There will be hundreds of PhDs, thousands of papers, very few cross the barrier like you just said. So can you quickly then talk about your philosophy or an example of when you said no? Somebody came and said, I have a wonderful idea, and you said, you know what? No, I don't want that.
Ooh. We will typically answer. We never say no, but we say yes. We say no for this one, but this is what we can do. This is what may help you even more than your question, your original question.
So we have a policy that when every year we have kind of like a process that when we vet new ideas that come to us, and we have a policy of only approving maximum 50% of them. So I'm not going to give you examples of things we didn't do, but that is, you have to say no to some things. Otherwise, you will be too diversified and will be just so in a lot of things.
As an ex-TNO, I can tell you that defining a business plan or your idea is key in that R&D center. Any further questions? I have two more questions. Please remind us your name and company.
Yeah, Robert Harrison, my name. I'm a board member of the European Quantum Industry Consortium and also an IP lawyer professionally as well as an investor. Both of your organisations have been extremely successful at establishing startups and spin-outs from the organisation. And yet one of the things that we've started also seeing that other RTOs have been pushing back, particularly the investors want exclusive access to the intellectual property behind some of this, and yet the RTOs have been pushing back and saying, okay, we cannot give you this, partly because it's public money behind it, the taxpayers don't want to do it. How have you managed this conflict within your organizations?
Well, in our case, we have a very broad variety of models on how we engage in our industrial relationships. But typically, and I think startups have been very successful recently as we are focusing more on the application domains. All these startups, they need access to technology platforms. Those platforms we typically keep common among various opportunities. We will never give exclusivity on the technology platforms, but in the application domains, we will give exclusive IP so that the startups can really find define a strong business plan and create a strong success story. But of course, as they need to leverage technology platforms, I mean, they can never pay for the entire platform. So giving them access is what is their need. So they don't need exclusivity.
Yeah, we do it the same way. We're reasonably flexible, but of course everybody's trying to maximize this position. I can understand that, and we also see investors that have more or less this attitude that we've been working on a technology for 20 years, invested a lot of money and a lot of effort in it, and then when time comes to spin it out, they want 100% of the shares and all the intellectual property. That won't work for us. So we do want to see that we also have a good position in that company, and that the technology is used in a good way and can be diversified to other fields if necessary, because certain technologies can be used in many different fields. So we always have to be aware of that. We're flexible, but up to a point.
From Photonics 21 is going to comment a lot on the investment panel tomorrow. We have one final question. Please remind us your name and company.
Hi, my name is Wenko Subtetz from the German Industry Association Spectalis. Luke, you mentioned we need the best of the best in photonics to master the challenges. There are other high-tech industries who compete for the same talent pool, also other regions in the world who compete for the best talents. What are your strategies to get the best talents for your company, for your institutions?
Go ahead.
No, please.
In our case, it might be not something that is on the mind of technologists often, or maybe they don't want to have it on their mind, but having a strong brand name is very important for people to gravitate towards the organization. So we haven't had that problem really in the past years. We've been able to hire all the people that we wanted to hire, but there's a big but. 40% or something like that is coming not from the Netherlands. So in the 2 years since I am now CEO at TNO, this organization has changed from a Dutch-speaking organization to an English-speaking organization completely, because of all the inflow of people from all over the world. I think it's a good thing. But you have to have, as I said, everything ties into what's the image, what's the brand saying to you. If you are very strong in certain fields, that alone will attract talent, right? If you're the leading innovator in certain fields, that alone will attract. But then also you will have to tell the story, and people will have to know about it. Otherwise, they won't know about it and won't want to work for you. I guess it's not much more than that.
Maybe, I just can add brand, extremely important. We also have a strategy where we partner with hundreds of universities to create an influx of talent to us and to this industry. We have about 850 PhD students who make their PhD. They obtain it from the university, but they do the research part in imec. And then thirdly, I strongly believe in the need to set up strong talent development programs. And we do that in partnership with universities, in partnership with our industry partners. But this industry needs a strong influx of talent. It's also one of the key priorities in the European Chips Act, or in the Global Chips Act, equally so in the US and in Japan. But I think it's these three pillars. But talent development remains a very important priority, because it's also our role as RTOs to bring up the talent to support our industry partners with their needs.
That's one thing I forgot, is that it's very important to signal your purpose and so the meaning of what you're doing. If you're just doing technical work in a lab, people, especially this generation, they want to have meaning, right, in their work. So we always kind of stress, what are we trying to create here? What technologies, what end goals are we trying to achieve using the technology instead of just focusing on the technologies?
Sure. I guess it's almost lunchtime. Jose is giving me the hands up. So thank you to both of our speakers.
Okay.